So today we're doing notes over absolute value function transformation. This is section 2.4, and we're going to talk about the graph going up, down, left, right, vertical stretch, and compression. Okay, transformations are change from the parent function. Okay, that's what a transformation is. You are a transformation of your parents. Okay, you are comparing how function has changed. I don't think that's grammatically correct. Has changed. Did it go left, right, up, and up, down, stretch, compress, and or reflect? So this is our transformation form. When we are in transformation form, basically what's happening is each variable plays a role and has a part. And so the A in front has its job, H has a job, K has its job. And in terms of an absolute value function, which is what we're doing, f of x equals plus or minus absolute value x minus h plus k, right? So in terms of that, we have our rules to follow. So when you have a k on the outside, that causes the graph to go up and down, okay? If k is greater than 1, which means positive, it's going to go up. If k is not 1, 0. If k is less than 0, that means it's going to go down. That means that the value is negative, okay? X is the opposite. X is our x's are liars. It's the opposite. If h is greater than 0, it translates to the right, but it's not going to look like it. It's going to look like it's negative, but it's if it translates to the right. If h is, I don't know why the inequality went that way. If h is less than 0, it translates to the left. So we have positive, negative. And remember, x is a liar. And that's because in the form, it's already a negative, and that's why it's presently positive. And then when I make it a negative, it's going to end up looking like a positive. So just remember that it looks like this when it's positive, and it looks like this when it's negative. Next, vertical stretch and compression. That's our A. It's asking, is it getting skinny or is it getting wider? So if A is greater than 1, it's going to get narrow. That means that it's growing faster. So the functions decide to go to the gym and get skinny. Okay. If A is less than 1, but A has to be greater than 0, by the way. If A is less than 1, the graph is getting wider, and that's just meaning that it's smushing down and getting shorter. So we have if it's skinny, and then it has wide or getting wider is what it's saying. And then here, the graph of the parent function is reflected. So there's a negative outside of the absolute value bar, and the graph of the parent function is being reflected. So let's apply all of this. And if you don't get it written down as of right now, please make sure you just go back to Canvas and look at the notes and write down everything that you feel like you still need in your notes. All right, so to analyze without a graph. So analyzing without a graph, there are 3 things we do. 1, we identify all the variables. What's our H, our K, our A, okay? And then identify the vertex and the axis of symmetry. So my vertex and axis of symmetry, HK, and x equals h is the axis of symmetry. And then we're going to describe how the graph physically changed. Did it go up, down, left, right, stretch, compress, or reflection based on what our A, H, and K are. So here we have the parent function. When we're going to compare it to y equals absolute value of x minus 1 plus 2. So we're going to compare this to our parent function. The first thing we're going to do is figure out what is the vertex. So we're going to find the vertex, and our vertex here Remember, it's your H, comma, your K. And then your axis of symmetry is whatever your X equals your H. So we're going to identify what each one of these are. So our A currently is a 1. Our H is also currently a 1. And our K is currently a 2. So identify the variables. And now when I plug them in, I have my vertex is H comma K, so 1 comma 2. My axis of symmetry is X equals 1. And because of what I have here, so it says A equals 1, because A equals 1, I am just a regular up-facing absolute value. I didn't stretch, I didn't compress, so there's no change based on my A. So it didn't change because of the A. Okay, my H equals 1, so since my H equals a positive 1, that means I am going, my graph is shift right 1 unit. And my K, since my K is a positive 2, that means my graph is shift up 2 units. Benja, I tried to stall and wait for you, buddy.
It's fine. He's a math whiz.
Okay? And that's what it's wanting you to do. So identify variables and say what the variables are doing to the function. Questions so far?
None.
Cool. All right, let's try another one. So for this one, we're going to identify our A, our H, and our K. A, H, K. So for this one, our A is 3. Our H and K are both 0. So therefore, my vertex is going to be at H comma K, which puts me at 0, 0. My axis of symmetry, which is X equals H, is going to be X equals 0. And this time, my A is changed. And so since A is greater than 3, I mean greater than 0, that means that we have a vertical stretch by 3. And since H and K are both 0, there is no shift. There's no horizontal shift, and there's no vertical shift. Right, horizontal, vertical. And you've now described what's happened. You identify the vertex, the axis of symmetry, and you describe what took place.
Wait, Miss Jones.
Yes.
I thought if A was greater than 1 instead of A was greater than 0.
Oh, thank you. Good call, Sarah. I just made A positive, meaning that it was no reflection. Thank you, Sarah. So if A is greater than 1, it's a vertical stretch. If A is between 0 and 1, it is a vertical compression. Okay. So here we have another one. And this time we have a whole lot of things happening. So our A equals -3. But we're going to look at the absolute value of our A, which equals 3. So the negative does its own thing. And then our H is actually -1, and our K is +2. Again, our vertex is made up of our H, comma, our K. So our vertex is -1, 2. Our axis of symmetry is our X equals our H. And that leads us to X equals -1. And our A. So notice that there's a negative. So the negative tells us one thing, and then the absolute value of our A tells us another thing. So because there is a negative, that lets us know that we have a reflection over the y-axis. No, they're wrong. X-axis. I was thinking X equals 0. I meant Y equals 0, which is the X-axis. Okay, and again, our A is greater than 1. So therefore, we have a vertical stretch by 3. Our H equals -1. So that means we have a, I'm going to write horizontal, so that you can know that that's going left and right. They have a horizontal shift to the left, 1 unit. And then we have a vertical shift to the up. That's not how you say that, to the up. We have a vertical shift up 2 units. I don't really know if periods are required. I'm really not making.
Periods aren't required until 3rd or 4th period for me, because that's my English class.
I don't have an English class anymore, so it's all out there. Okay, so yes, identifying all the variables, what their roles are, what their jobs are, what they do, how it affects, and you're doing it all without a graph. You're doing it based on understanding what each variable does and the effect that each variable has on the graph. So that is the end of today, but I wanted to go back so that you can see it. And then on Monday, yay, Monday we're back to normal. We will have some more practice with transformations, face-to-face.